Good morning everyone. I am Tanushree Dalai from Civil Engineering branch. So in the last class, we have already calculated the shear forces of this particular beam. So now we will draw the shear force diagram for this beam according to the points that we have got. So first of all, the shear force at point A will be 8 kN. So first of all, we start the shear force diagram. We need to draw a reference line for the easy drawing of the shear force. So at point A, we got the value of shear force as 8 kN. So we can put here one point above the point A. After that, at point C, the value of the shear force is 4 kN. So it will be nearer to the here. After that, at point D, the shear force of the point C is continuing up to the point D. So here also the value of shear force is 4 kN. After that, from the point D, the shear force change its sign, and at point E, it will be minus 4 kN. Then this minus 4 kN is continuing towards the point F. So here is one point. After that, at point F, the shear force value is 12 kN. Then this 12 kN is continuing towards the point B. So first half of the shear force diagram is in positive and second half of the shear force diagram is in negative. So here you can see one point is there, that is the point of contra, we can say, and we introduce this point as point G. So we know that the point at which the shear force will be 0, in this particular point, the bending moment must be maximum value. So that we need to know the distance of this point from any support of the beam. That may be A or that may be B. So, to find out the distance of this point, we need to take a help of similar triangular section. So you can see from this point G towards the left side, and this section is look like a triangular at the upper side. Again, at the lower side you can see this portion of the section is look like a triangular section. So by the help of these two triangles, we can find out the value of this G from any support of the beam. So consider that DG will be X, and we know the value of DE will be 4 meter, which is given in the question. Hence, if we consider DG will be X, then GE will be 4 minus X. So, according to similar triangular section, we can put the base of the first triangular, that means this triangle, divided by P is equal to the base of the second triangular, that means this section, divided by P. So we can write the base of this section is DG, which we considered as X. So X by this portion will be 4 kilonewton, that is 4. Again, for the second triangular section, this portion will be 4 minus X, and the value of P will be again 4. So here negative sign is neglected. So we can put X by 4 is equal to 4 minus X divided by 4. So from this equation, we can get the value of X, which is 2 meter. By solving this equation, the X value we got as 2 meter. So 2 meter is the distance between D to G. That means here to here. So the total distance from the support will be here 2, and C to D the distance is 1 meter, and A to C the distance is 2 meter. So the total distance is 2 plus 1 plus 2, that is 5 meter. So we can say the point of zero shear force, that is G, is situated at a distance of 5 meter from the support A. Hence, the bending moment at point G will be give a maximum value of Bm. So now we will calculate the bending moment calculation, and after that we will draw the bending moment diagram as per the values. So as we know that it is a simply supported beam, so that at the end of the beams, that means at point A and at point B, the value of bending moment will be 0, because at point A and at point B only forces are there and no distance is there. So that we know to calculate the bending moment, we need to take two things. First one is your load and second one is your distance. So due to no distance, the bending moment at point A is 0 and bending moment at point B is also 0. So rest of the points are at point C, at point D, at point E and at point F, and another point is G. So when we will calculate the bending moment at point C and D, we need to consider the left side of the portion, because it is easier to calculate from this side. And when we will calculate the bending moment at point E and F, we need to consider the right portion of the section. So we can calculate all these things from one side also, because it is a simply supported beam. For the easy calculation, we need to calculate the sides which have less amount of loading condition. So first of all, the bending moment at point C, that is MC, is equal to, consider this portion. So look at the left side of the section, where only reaction at A is there and the distance of this reactions to the point C is 2 meter. So we can say the bending moment at point C is equal to load into distance. That means RA into 2 meter. So your RA value is 8 kilonewton and distance is 2. So 8 into 2, which is equal to 16 kilonewton meter. So now we will calculate the bending moment at point D. So you can see here also we have to consider the left side of the portion because here the less amount of loadings are there. So here 2 loadings are there to calculate the moment at point D. So here is one reaction and here is 1 point load. So first of all, calculate for this point load, which is reaction at A. So RA into distance up to D is 3 meter. That means here to here 3 meter. So load into distance will be RA into 3. And it is give a sagging moment, so that we will take here as positive moment calculation. After that, for the point load, it is 4 kilonewton and the distance between C to D is 1 meter. So the load into distance will be 4 into 1. Hence, the bending moment at point D will be 8 into 3 minus 4 into 1. And the sign of this portion is negative because this 4 kilonewton give a hogging moment towards the point D. So that here 8 into 3 minus 4 into 1, which equal to 20 kilonewton meter. Now we will calculate the bending moment at point E. So as I said in before, for the bending moment at point E and the bending moment at point F, we need to consider the right side portion of the beam because the right side portion having less amount of loading as compared to this portion. Okay. So now for the calculation of bending moment at point E, we need to look at the right side of the section. So here is one loading condition and here is another loading condition. The total loading condition is 2. So for this reaction value, that is RB, the moment will be this load into distance up to E. So the distance up to E is 2 plus here is 1, that is 3 meter. So total moment for this reaction will be RB into 3. Okay. So RB value is 12 kilonewton and distance is 3. And again another loading condition is 8 kilonewton. So the distance between this point load to the point E will be 2 meter. Hence the moment calculation for this point load is 8 kilonewton into 2 meter. And the sign will be negative because this point load give a hogging moment towards the point E. So we can write 12 into 3 minus 8 into 2. So as a whole, the value will be 20 kilonewton meter. After that, we will calculate the value of bending moment at point F. So here, we will see the right side of the section. So at the right side, one load condition is there, which is RB. So we can write the RB into the distance from here to the point F, that is 1 meter. So we can say the bending moment at point F is equal to RB